In this fall, I joined a research team in our college called iRisk Lab, and basically what it does is to research on popular topics for quantitative finance and actuarial science, and it develops a decent idea for practical use. Our team consists of 4 students and 1 professor, and our research topic is the visualization of sample recycling method for nested stochastic modeling. So the sample recycling method is developed from the Monte Carlo simulation, and the Monte Carlo simulation involves a lot of computation to determine the discounted expected value from different scenarios. So the sample recycling method can reduce those calculations needed by reusing sample path that is derived from a reference point, which is calculated by the Monte Carlo simulation. And beside of the sample path, for other path, we can calculate the density ratio to conduct other path to the sample path by the density ratio, and we can calculate the probability that other path will go to the sample path. So based on the original idea about the research, we conduct our research to first generate a reference point at time 0 by using the Monte Carlo simulation, and that will be used as a sample path later. And by the way, we use the European option in this example in our research. And so we successfully priced the Euro option at time 0 by using the Monte Carlo simulation. But in the next step, we face some difficulties. So we try to reuse the sample path by calculating the density ratio, but we noticed that the outcome we calculated is pretty different from the outcome that is calculated by the traditional method. And this is a really big problem because even though the sample recycling method saves times on calculation, but it will generate an inaccurate outcome. And after researching our method, we found that we need to change a way to determine the density ratio. And we use another distribution called log normal distribution that is based on assumption of geometric Brownian motion. And we apply our new method to determine the density ratio, and the outcome turned out to be good because the outcome is just slightly different from the outcome we expected. So the difference is really small, and that can be totally tolerated in the real life scenario. So I think this research experience is really helpful for my intended career in quantitative finance, because the research topic involves a lot of work in quant positions, such as pricing the option or speculating the stock index. And for another point, I think I can use those skills to do the work very fluently because those topics became very familiar to me. And in addition, I think this experience can improve my ability to work in a team. And during the research, we split our work very clearly, and we collaborated in a very good efficiency. And so based on what I know about the quant position, it demands a lot of skills in a teamwork environment. For example, a team will consist of 2 quant developers and 1 quant strategist and 1 trader. And those people have different responsibilities, but they need to collaborate very tightly. So in general, I think this experience is very helpful for my future career in quantitative finance, and I would like to explore more about it under the instruction of your esteemed master program. Thank you.